So this time we have an RL combination. Okay? If the value of V at time t is equal to 0 negative is 50 volts, what is I and what is V? Wherein your I here is the inductor current and your V is the resistor voltage. How is a resistor differentiated with a capacitor? Resistor parameters like your voltage and current can change its value abruptly, okay, or immediately with no time elapse, okay, whereas for current and capacitors, they cannot change their parameters, specifically the current and voltage respectively, without any time elapse. Okay, so if we start at time t is equal to 0 negative, meaning before the switch is thrown open, the initial value of V is 50 volts. What is the value of I and V after the switch is open? Okay? Since it has already reached its steady state value, your inductor will behave like a short circuit. The other parameters like your resistance will remain the same. This is your V, where your 75 ohms is located. This is your 10 Henry, 50 ohms, 150, 25, and 100 volts. Okay, this is your I at time t is equal to 0 negative. This is your V at time t is equal to 0 negative. Okay, and just the same, we can obtain your I simply by solving for your or applying your current divider. But first is we need to determine the total resistance. Okay, total resistance is 25 plus 1 all over, yan, 1 all over 150 plus 1 all over 50 plus 1 all over 75, and the total resistance is 50 ohms. Okay, total resistance is 50 ohms. So we can have here the total current. Total current is 100 all over 50 is 2 amperes, and we can determine the value of I before the switch is open, okay, by applying your current divider rule. Okay, so your I at time t is equal to 0 negative is 2 amperes times, okay, the parallel combination of 150 and 75. 150 times 75 divided by 150 plus 75. 150 times 75 all over 150 plus 75 plus 50. The value of I at time t is equal to 0 negative is, okay, this is equivalent to 50 divided by 50 plus 50 times 2 is 1 ampere. Okay? And since your I at time t is equal to 0 negative is the same as your I at time t is equal to 0 positive, your I at time t is equal to 0 positive is equivalent also to 1 ampere. That is one of the characteristics for an inductor current. Okay. Next, how do we find your V at time t is equal to 0 positive? If you are given a requirement like this, you proceed to the time when your switch is just activated or just open in this case. So at time t is equal to 0 positive, okay, here is how your circuit will look like. Still, your inductor is a short circuit. Yan. So this is 125. This is your total current. The current here is your I at time t is equal to 0 positive. This is your V at time t is equal to 0 positive, which is your 75 ohms, 50, and 150 ohms. To obtain the value of V at time t is equal to 0 negative is for you to determine the current going into it. That is to say that your inductor now is like a source of power. The electromagnetic energy that is stored across the inductor coils will now be released to be compensated by the three resistors, namely 50, 150, and 75 ohm resistance. Your I at time t is equal to 0 positive here is 1 ampere. Okay? Supposing that the current here is Ix by current divide rule, your Ix is 1 ampere times 150 divided by 150 plus 75, and that is 0.667 amperes. So therefore, your V at time t is equal to 0 positive is 0.667 times 75. So times 75, that is 50 volts. This is now the value of V just before the switch is open. 50 volts. Okay?